one of those transition metals, and it's not zinc, cadmium, or silver. I know in the name I am going to have to go ahead and give it the charge in the name. So here's where you have to kind of, it's almost like a reverse crisscross, the way I think of it. You have to write the component ions, you have to think of, well, what charge would Fe be then? So, yeah, what charge would Fe be then? What is it? It's a +3, and how'd you get that? Kind of like a reverse crisscross. Because we know that oxygen is always going to be a -2, right? So we have filled that in. And you got to know that Fe +3. And this is where sometimes students, so what would the first name be? Iron 3, yeah. A very common mistake I've seen is students will want to go, and what would the last name be? Yeah, oxide. A very common mistake is students will want to go, well, it's iron 2. I have 2 irons. It's iron 3 because of the +3 charge. That thing in Roman numerals doesn't say how many of those you have, it says what the charge is. And you can deduce the charge on the cation from the given charge on the anion. Yep. It's all good till somebody gets hurt. All right, so let's look at, let me roll out the last part and see what y'all think. Oops, that's not what I want to do. Oh, drat. Maybe when this happens. Okay. Oh, goodness gracious. All right, so the next part introduces polyatomic ions. The word poly means more than one. Atomic means atoms. Ions means charge. So we have more than one atoms that are floating around with the charge. So if we pick on, let's see, yeah, this way. If we pick on this guy right here, you're going to have to memorize, that the name is ammonium and it has these 5 atoms. You don't have to memorize this, but think of it as like this. Okay, that's the nitrogen, and it has 4 hydrogens all floating around with a +1 charge. Okay, it's a polyatomic ion. Now, we can crisscross within, just like we crisscross with anything else. Most of your ions are going to be anions, negatively charged. Actually, if you would, on page, you're going to be flipping back and forth, on page 285, 2.85, if you would, go ahead and add these 2 at the bottom, that would be great. So write ammonium, and then write NH4 plus, or +1. And then write mercury, Roman numerals 1, and then write Hg2, 2 plus. That would be great. So do you see what I'm talking about? All the other ones, and we'll be talking about these a little bit, so you're going to have to remember. These I have flashcards for. So you can earn 10 extra credit points if you cut out flashcards, pull them over. Now let me pick on Hg2, 2 plus just right quick. So the little subscript 2 here means that I have 2 mercury atoms. So Hg2, 2 plus looks like this. That actually is a chemical bond. You cannot break that. And it runs around with a +2 charge. So you're like, oh, really? Yes, it's a polyatomic cation. And it goes, to me, kind of by mercury 1. I think of it this way, as each one of those Hg's, which you can't split, are kind of +1, so together they're +2 because of 2 of them. Okay. Not to be confused, and I don't want to confuse you, that's not what I'm here for, but we definitely have this monoatomic form of mercury, 1 atom, because there's one there, with a +2 charge, and that is Hg parentheses Roman numeral 2. Don't blame me. All right, so let's talk about the anions. Well, most of the anions have oxygen, okay, but these don't have oxygen. So on that page, if you find carbon on that page, like the one I had you write on, if you find carbon, you're going to find CN. The name is cyanide. It's CN -1. Okay, is thiocyanate also with C, or is it with S, or is it with N? All of them.
It's with S.
It's with S.
Yeah.
SCN, thiocyanate. I guess it begins with an S. Okay. Triiodide, is that not fun or what? We have 3 iodines. They're stuck together collectively, and they run around with -1 charge. That's so fun. Okay. What else we got? Well, if you have something that has oxygen, oftentimes they will end in ite or ate. These are exceptions. The hydroxide ion, which maybe if you've kind of dabbled with other chemistry in other areas, you definitely know that's a player. Hydroxide is 2 atoms stuck together. They don't come apart unless they chemically react, and they have collectively a -1 charge. Cyanide, we talked about before, triiodide. So let's look at the ones that have oxygen. The oxygen polyatomic ions are called oxyanions. Makes sense. And there's where you're going to run into your troubles. I'm going to try to kind of give you some hints. A lot of them end in ite and ate. Find nitrogen on there. Find nitrogen. Okay. So you have 2 oxyanions of nitrogen. So which one has less oxygen? Nitrite. That's always going to be the case. Find sulfur. 2 different oxyanions. Which one has less oxygen? Sulfite. That is always the pattern. Ite has less oxygen, relatively speaking. But if I pick on sulfur, the sulfur containing oxyanions, and then nitrogen containing, they don't have the same amount of oxygen, do they? And their charges are different. Oh, don't blame me. Okay, so that should hopefully help. Yeah, so 2 examples. You guys found sulfite, but this took me a while. Within the same group, they have the same charge. That should help. Sulfite and sulfate, -2. Nitrite and nitrate, -1. So there you go.
But like,
Oh, no. You answered your own question.
no, just like, if I only have like SO3 -2, but I don't know like the other one, like I don't know the sulfate one, right? I just know I have like this 4 one.
You have the formula, but
Yeah.
you don't have this one?
Yeah, how do I know that it's like, I mean,
You just had to memorize.
okay.
Yeah. I don't know why it is actually.
Well, like the nitrate, yeah. It's like 3 - 2 is 1, and 2 - 1 is 1, so it's nitrate. And sulfate, like 4 - 2 is 2, 3 - 1 is 2.
Well, if it works for you, I don't follow it. It might be. It totally might be. I'd go with it, Allison. Yeah.
You guys see that?
Yeah.
I see the nitrate. I just like go. Oh, okay, yeah, okay.
Well, there's also a phosphate. I don't know if I had phosphite under. There is a phosphite, so I don't know if it does the same roles. But the way I remember it is like I ate too much oxygen, so 8 is always like maybe more than ite. So I know, right? Okay, so look at your halogens. Look at that page. That is some crazy stuff there. For each of the halogens, beginning with chlorine, I think. Yeah, you have 4 different options for combining with oxygen. But what's the charge in each case? -1, it's gotta help, right? So smack dab for each of those halogens, smack dab in the middle, you have your ike and 8. Okay? And then what you do is, if you are hypothermic, what are you? You're freezing cold. You're low on thermal energy, hypothermic. So actually, if you're low on oxygen, we put hypochlorite. So low on oxygen, hypothermic, hypochlorite. Ike means it was low anyway. Hypo means extra low. And I don't know how we do this. We do another prefix for if you've got more than 8 or per chlorate. So chlorate is 3 oxygens, perchlorate is 4. So you have 1, 2, 3, and 4 oxygens. And this pattern goes, thank goodness, the same through all of the 3 halogens, the chlorine, bromine, and iodine. Okay, so don't blame me. All right, I think the last hint is this one. If you kick a hydrogen onto your polyatomic ion that has oxygen, you kick a hydrogen, you're like adding a +1 to collectively your charge. So it kind of dampens down the charge 1. Okay, so if it had a -1, if you add a hydrogen, it's neutral. If it has a -2, you add 1, then add 1 hydrogen, it becomes a -1 instead of -2. If it has a -3, you kick in a hydrogen, that's like canceling one of those negatives. So it goes from a -3 to a -2. The best example, well, there's a couple examples. There's one with sulfur, there's one with phosphorus. That's really good. So we have sulfite, SO3 2-. Then if you look first under sulfur containing polyions like this, we have hydrogen sulfite. And another name for hydrogen sulfite is bisulfite. Some people learn bisulfate. Bisulfite. Careful. So you see where I have to be rude like sulfite, sulfate, and be rude like AI. Okay. So, but can you see it went from a -2 to a -1? Sulfate, hydrogen sulfate goes from -2 to -1. Carbonate, hydrogen carbonate. Now, when you get to phosphate, you get a little more play in it because the phosphate polyatomic ion is a -3. So if you kick in 1 hydrogen, it goes from -3 to -2, and we would call that hydrogen phosphate. If you kick in 2 hydrogens, it goes from a -3 to a -1. This is called dihydrogen phosphate. There's only maybe 2 places where you use the word di. And I don't want to set anybody up to get confused on your test, but there's so many times on your test where I'll see people, what's a good example? I even hate to, but maybe this will help if I write it down. Like if I was going to combine, what would I was going to combine potassium and sulfur, K plus and S2-. You'd say I need 2 potassiums and just 1 sulfur will do me, right? Okay, so I'm going to say this quietly so you guys don't let it embed in. I have so many times people will do dipotassium sulfide. Oh, no. The only few times I'm using di. The only other time, so dihydrogen phosphate. The other one is, you guys have chromium? Yeah, dichromium. It's the only other time we use di. All right. All right. So let's go ahead and randomly pick something together. So this last part, the metal could either be what you hang your hat on, no Roman numerals, including zinc, cadmium, and silver. And then it could also be polyatomic. So let's pick 289. Trying to pick one that, let's pick on N. Let's do N together right quick. So N would look like this. So we are going to combine, what does CO stand for? cobalt, very good. We're going with a +3, and so cobalt is definitely going to use Roman numerals, right? And we're going to combine that one with, what does NO2, what's the name of that? -1. Nitrite. Yes, very good. So if we crisscross, how many cobalts do we need? Just one. So I could put a 1 there or not a 1. How many NO2s, excuse me, do we need? 3. And since we need 3 NO2s, I'm going to put NO2 in parentheses, and then outside the parentheses, I'm going to put my 3. And what's the first name of this compound? Cobalt. Roman numerals or no? Yes. Cobalt 3. So many things to remember. And what's the last name? Nitrite. Yeah, all sorts of things. And then if you go onto the net or flip that page over, let's pick on G. Now on your test, if I give you a name like this, I'm not going to say to write its component ions, but in the lab you need to, and I would suggest you do it on your homework and on the test. So the name we're dealing with is lithium perchlorate. Sounds official. Lithium perchlorate. For the lab, you got to write the component ions. So what's the component ion of lithium? Li+1. Yep. How about perchlorate? How many oxygens? ClO4, perfect. And then what's the charge? -1. So if we crisscross, how many lithiums do we need? 1. And if we crisscross, how many perchlorates do we need? 1. This is an example. With my intro students, I say go ahead and put ClO4 in parentheses if it makes you feel better, put a 1 outside. But for y'all, probably not, because that's not the way it's done. Okay. All right, turn you loose, and before I turn you loose, just so I have to say it one time, I